In this video, I'm going to be talking about what I think are the 4 most important things to consider regarding your portable power station, or if you're thinking about buying one. These 4 things will help you prepare for and get through a power outage. I'll be using my Delta Pro as an example. Now the setup I have is a Delta Pro with 2 extra batteries, so it's 120 volts, 30 amps. Now I've never received any incentives from any manufacturer for anything that I've talked about on my videos. I've been offered incentives many times to do reviews, but I've refused. Until now, Ecoflow gave me an extra battery for my setup if I would include hashtags under the description, and if I would talk about how Delta Pros helped us through power outages and so on. I've already done that before. I've done a review on the Delta Pro and turned the power off in an all-electric house, and it worked out fine. I did a review on my Delta 1300 before that, and I own several Ecoflow products. So it's no surprise that I like Ecoflow, but I wanted to share that with you that I got a battery from them. Now, the 4 most important things you want to consider regarding your portable power station, or if you're thinking about buying one to help you prepare for or get through a power outage, are 1, what I call the heart of a portable power station; 2, how to connect it to your home or not; 3, how to establish what I call a baseline; 4, what you can run and how long you can run it. And I did a 3-part video series that is much more detail about that. I highly recommend that if you want to check that out on my channel. This will just be a summary. And then finally, we're going to do a 24-hour power outage by turning the main off and showing you how this works. Now, what I'm talking about when I say the heart of a portable power station, I'm talking about battery capacity, continuous running watts, and surge watts. Battery capacity refers to how many watt hours your batteries can hold. In the case of the Delta Pro and 2 extra batteries, that's 10,800 watt hours. Now, I can't use all of that because the Delta Pro needs to use some of it in order to run with the inverter. So in order to find out how many watt hours I can use, I did a battery discharge capacity test, and I have a video online that shows you how to do that. It turns out I can use 92% of that, which is very efficient. And all I do is I multiply 0.92 times 10,800 watt hours, and it turns out that's 9,936 watt hours that I can use. I'm going to round that down to 9,900. Now for you, if you're thinking about buying one or you have a unit, just research inverter efficiency percentage or battery discharge capacity test and see if you can find out what yours is, or ask the person you bought it from. If you can't, then I suggest using 85%, 0.85. If you have a 1,000 watt hour battery, for example, that would be 850 watt hours. You just multiply 0.85 times 1,000. If you go under the description in the video, you can download and print out this page right here. And you just take that, in that example, you just take the 850 and you write it all down on all of these lines here, and you multiply it straight across to get another number here. So you just go 0.95 times this number to get, or your 850 to get whatever it is on this side. And now here's an example of mine with the 9,900 watts. I went ahead and I wrote in or typed in the 9,900 all up and down here. And I multiplied, for example, here 0.95 times 9,900, and I came up with 9,405. This will take about, 4 minutes with a calculator. Now, I'll show you what to do with this a little bit later. Now, continuous running watts are important to know. In this setup, it's 3,600 continuous running watts, and I can run pretty much anything I want. Now, you need to know what that is so you can figure out how much you can run at the same time. And then surge watts for this unit is 7,200 watts, which is really good. I can run, again, just about everything that I own in my home. So you need to know what your surge watts are, and I'll talk a little more about that later. The second most important thing you want to do is decide whether you're going to hook up your unit to your home, if it's large enough. If it's too small to do that, don't worry. You're still going to get a lot of good information later in this video. I think it'll be very helpful. But when I first got my Delta Pro, we were in an all-electric home at that time, and I'm not going to put it in the garage. It's too cold in the winter, too hot in the summer, too dirty and dusty. So we put it in our kitchen and then put an outdoor inlet in the kitchen. It was ugly. It was this big box. So in this house, I decided to use an RV inlet. It's just more streamlined. It's just a little easier on the eyes. Now, I also have a dual fuel generator. We use propane with it. Store it in the garage, and when I want to use it, I put it in the backyard, and I have an inlet for that as well. I'll explain a little later how I use this and use my Delta Pro. Now, depending on which one I want to use, I have a switch right here that I can just click it up if it's the Delta Pro, or click it down for the gas generator. I do this to isolate it so that there could be no mistake made. You don't want to run them at the same time. I had something like this on my other home as well when I did a video about this, but I forgot to show it, so I'm showing it now. I use an interlock system in the breaker box instead of a transfer switch. I do that because I want to be able to use all the breakers I want and then control the power in my house. The problem with an interlock is you never know when the power comes back on. But I have an alarm right here, and all I have to do is turn it on after the power goes out. It's connected with a wire wrapped around the cable that comes into, from the utility company into the box, and before the main. So when the power comes back on, the alarm will go off and let me know. That's really important to me because I want to be able to, on a rolling blackout, I want to be able to charge that up immediately, as soon as I can, take advantage of when the power's on. Now I'll be showing you how all of this works in the 24-hour power outage in more detail. Now the third thing you might want to consider is establishing what I call a baseline. Now a baseline is how many watts your home will draw from your battery when the power's out, your generator or portable power station's on, the breakers are on that you want to run, everything is plugged in except the refrigerator, and everything is turned off. Because you're going to have phantom loads, your TV might be drawing, your computer, you might have your smoke detectors hardwired, security cameras, things like this. So you want to find out that baseline. What is the bare minimum, even without the refrigerator, what's the bare minimum watts that will be drawn? Now I have my router and my security video recorder also on that baseline because I don't want to reach in and try to unplug everything. So that my baseline ends up being around 80 to 100 watts, mostly around 100. So that's what I'm going to use for my baseline. So the last thing you might want to consider is to figure out what you can run and how long you can run it. Now I have that 3-part video series that gets in detail about that, and I highly recommend watching that. But we'll start with the refrigerator right now. If I plugged that in when I tried to get the baseline, I wouldn't be able to find a baseline because it would be bouncing all over the place. That's why I unplugged it to show you how to do the baseline. So you can't tell really how many watt hours are coming out every hour per hour on average. So you can't calculate how long your battery is going to last. Even when it says 10 hours, that's going to change to 6 or 7 or 9 or 11. It'll bounce around because it fluctuates. So the answer is you use a kilowatt meter like this. Now I've used this for years. Under the description you can learn more about it. And it works really well. I plugged the refrigerator in for 24 hours, pushed the button right here, and I saw that it used 1.54 kilowatt hours in that 24-hour period. I want to know how many watt hours. So all I have to do is add a 0 at the end. That's 1,540 watt hours divided by 24. That's 64 watt hours per hour on average. Now, if I only run it for 4 hours, then I would take that 1,540 divided by 4 hours, whatever it is. 64 watt hours per hour on average is extremely efficient. This refrigerator has an inverter, and I did a little review on it on my channel if you want to check it out. It's great if you have a portable power station. So 64 watt hours. Now, I did a test on my chest freezer as well, and that uses 40 watt hours per hour on average. So between the two, we're talking 100 watts. The surge watts on that freezer are 1,300. And if you want to find out how to figure out what your surge watts are, some people say you multiply the running watts by 3 or 4. That's not all that accurate sometimes. So I have a way to figure that out. You use a clamp meter and a line splitter and watch that three video series that I was talking about. If you want a shortcut, go to video 1 of that and go to about 16 minutes, 10 seconds, somewhere in there, I think it is. And I talk specifically about this and how to use these. Okay, well now I know that my baseline is 100 and my refrigerator freezer is 100. So I have 200 watt hours per hour on average being drawn out, of my battery. And if I have 9,900 watt hours, if it's full, then what do I end up with? About 50 hours left. That's just divided. 9,900 divided by 200. That's 49.5 hours left. It's good to know that when you're trying to manage the power. Now, I live in a house with natural gas, and I want to know what my furnace uses. So what I did is I shut all the breakers off except that dedicated circuit. Watched the Delta Pro and saw that it drew about 388 watts. Now, I'm just going to round that up to 400. Now, it does. If it ran solid for an hour, that would be 400 watts out. But it doesn't. It cycles off and on. It was 34 degrees out when I tested this, and I put a little tissue up on the register on the ceiling. My wife and I watched that for an hour and a half while we were watching TV, took turns. It turns out that it cycles off and on about half the time, which means that when I calculate this, I only have to use 200 watt hours because it's half the time. In the hour, it runs a half hour. So with 200 watts plus the 100 baseline plus the 100 with the freezer, we're talking 400 watt hours. Now, if my battery is full, it'll run for 24 hours. I know that because, or about 24 hours, because I just divide 9,900 divided by 400. So that's it helps you manage the power. But listen to this part. If it's 4 in the afternoon, for example, and I'm on a pretty full battery when I'm going to bed later that evening, and I'm cold, and I want to run my furnace, is it wise to do that? Well, it depends how much battery I have left. So what if I look at my battery and I see that there's only, let's just say that there's 40% left. Well, that's when you get this little chart out that you made earlier. Now, 9,900 watt hours, and I multiplied the like 0.75 times this is that. All I have to do is go to 40, which is here. I have 3,960 watt hours left. Now, if I divide that, 400, baseline, refrigerator, freezer, and furnace, if I divide that into 3,960, I'll have about 10 hours left. So that's the way you figure out how many hours you have left in a system like that. Now, let me move on to a couple other things that I checked out. The tankless water heater. They are so efficient. This tankless water heater is gas. It, of course, uses power as well. It's 120 volts, just like the furnace. And what we did is I went into the shower and turned it on maximum hot. Went back. All the other breakers were off except that one. On my Delta, I was running my Delta Pro. And it turns out it was using about 40 watts per hour on average. That is efficient. When we turned the hot water on in the kitchen, it went up to like 68 watts. So I can have that hot water on for a complete hour and only take 40 watts out. That's good to know because if it's freezing out, I can take a nice, long, warm shower. If you're in an all-electric home like we were in before, I have a video that shows you how to make a warm water bucket shower. So you might want to check that out. My microwave, it's rated at 1,700 watts in. You always want to make not out, you want to use the in. But it turns out it uses 1,850. But if I divide that 1,850 into 60 minutes, that's 31 watts per minute. So do I want to cook something? Do I want to heat up some mac and cheese or something like that for 10 minutes? Well, it'll cost me 31 watts per minute times 10. That's 300 watts. Is it worth doing? So those are some things that you can consider. How about a coffee maker? Our coffee maker is 1,025 watts rating. But it's really simple to do this. Just plug the kilowatt meter in and do your coffee. Turn it on, and then when it's done, and the coffee's nice and warm, look at your kilowatt meter and find out how many watt hours it used. In this case, ours used 150 watt hours. So I know what it costs me to make coffee. So that's kind of how you manage the power. So what do you do with all these numbers? Well, you write them down so you can use them if you have a power outage. It helps you manage the power. I do have this summary sheet you can download under the description and print out. If you can't make sense of this, then watch that 3-part video series that I was talking about. This is what it comes from. And but it'll help you organize just a little bit. And you can put them in a folder similar to this. I just keep them all here. My chest freezer, refrigerator, dishwasher. I have everything in here. So, and I keep this in the top compartment of my Delta Pro extra battery. Kind of just fold it up in there. So hopefully that'll help. Also, you with your TV and other appliances, it has a little label on the back. Well, just write down the maximum running watts for those kinds of things as well. Write them on in here. You can manage your power that way. Well, it's almost noon, and we're getting ready to start our 24-hour simulated power outage. My wife's on the way to the breaker box. She's going to turn that main one off any minute now. Now, we went through this just a few weeks ago during the Texas Arctic freeze. We shut the water off, we shut the power off, we didn't use a generator, we didn't use a portable power station. You might want to check that video out. Well, the power's out. Now what do we do? Now that the power is off, the first thing we need to do is unplug the refrigerator, the TV, and computer and printer. And the reason we do this is because when the power comes back on, there could be a surge that could damage the electronics. Even if the power comes back on the next 15 seconds or 30 seconds, it could be the same damaging surge watts. The next step is to plug in the Delta Pro and then turn it on. The next step is to turn the 30 amp toggle switch on to the Delta Pro. And now turn all the breakers off. And now move the interlock to block the main breaker and switch on the Delta Pro breaker. We're turning on all the 120 breakers that we want on. Okay, now normally you turn on the alarm right now, but there's still power coming into this the box from the utility company. If the power is out, that's a different story, but I'm going to go ahead and show you what this would sound like. Okay, so we plugged in the TV, the computer, the printer, the refrigerator, the freezer, and then we went around the house and made sure everything was turned off. Now I suggest if you're going to be running your TV to go to the settings and turn the power savings mode on, and maybe disconnect the external speaker and use the TV speaker. It's been pretty cloudy out. And it's been about 2.5 hours, 2:30. We have a really bad angle for the panels back there. I can't wait to get them on the roof, or the other panels on the roof. We're 92% here, 94, 94. Let's just call it 95. So we have about 9,400 watt hours available. If we're running only our baseline, refrigerator and freezer, that's about 200 watts. So it's 9,400 divided by 200 gives us about 47 hours left. But we've been running our TV and we're going to be running it again a little bit. It's only bringing in 138 watts solar, and 80 on one battery and 70 on another is going into the Delta Pro. That's why it says input 280. So we'll check back in a little bit. Okay, so it's 4 in the afternoon, so there's 20 hours left in this power outage. Estimating 90, 87, and 90%. We're just going to call this an average of 90. Now that would mean that we have 8,910 watt hours left at that point. Now we have to subtract what we plan on using. Let's see, the TV is about 120. So here's what it looks like. So for 5 hours of TV tonight, we have 600 watts total. Lights for tonight only, not tomorrow. It's 500 watts, we're estimating based on the bulb sizes. Now for 20 hours, we have the baseline and the fridge freezer. Each one will cost 2,000 watt hours with a total of 5,100 watt hours. So we should be able to squeeze by, because we have about, even if it were 8,000 watt hours, we should be able to squeeze by. But we're going to go ahead and charge this up anyway, the Delta Pro, just to show how it's done. We decided to charge the Delta Pro with a gas generator. We're going to be using propane. Now we're not using the inlet. I would use the inlet, for example, if it were if I wanted to preserve the power in the Delta Pro and run the gas generator, run this on the house for the last part of the day to save the battery in the Delta Pro. It just depends on the weather. But in this case, we're just going ahead and plugging in with this extension cord that an electrician sold me. Said that it's just fine, and it works well. I've used it several times. Okay, so let's start this up. We sealed up the doggy door here, and I'm not sure how much might leak through the door because the generator is just on the other side of the brick. I don't smell anything, but carbon monoxide is odorless. So we went ahead and put some carbon monoxide detectors out. Okay, let me just recap a little bit. We're running the gas generator on propane. It is not using the inlet out there because the Delta Pro is using the inlet. I haven't done anything with that toggle switch. Nothing's changed with the Delta Pro. We just plugged it in right here to the gas generator. Well, we wanted to stop early because the neighbors were having a barbecue, but we got 97% on the Delta Pro, 98% on one battery, and 98% on the other battery. Would have been 100% if we had more time. So this is what it was like walking through my bathroom door at night when the power is out. You know, I have my little lantern, and the first thing I do is hit the light switch, and there's no light. It would remind me that we are in a power outage, and after 3 or 4 days of that, that can get pretty depressing. There's something about being able to just, bam, you know, that's just, it has a calming effect, less stressful. And then if you're older, you're more prone to falls, and it's nice to have some light if you're walking around at night. And again, this can be depressing after 3 or 4 days, even if you have a lantern. But you know, there's still something calming about knowing that you have lights. It's a big deal. Okay, it's about 8:45, and I'm going to stop recording. We're at 94%, 89%, 90%, and I'm predicting that, well, that's about 90, 91% on average. So about 8,900 watt hours. We're going to be using mainly just the baseline tonight in the refrigerator and freezer, so that will be about 2,500 watt hours. So we'll end up about 6,400 watt hours in the morning. I'm predicting around between 8 and 9. Well, good morning. Last night at 8:45, I predicted we would have about 65% left in our batteries between 8 and 9 a.m. Well, it's 8 a.m., so let's check. Okay. So we have 62 plus 65 and 67. 65 plus 67 equals 194 divided by 3. Now that's pretty close. That surprises me. I'd be happy if I was within 5 or 10%. Anyway, this is what managing the power looks like. All right, we're looking at an output of 360 watts, and my wife's about to blow dry her hair, and that estimated maximum running watts 1,550, and when she's done, based on how long it takes her, we will use 110 watt hours out of our battery. Okay, so she's about to turn her hair dryer on. Okay, so we're making coffee with our coffee maker. Coffee maker has a rated watts of 1,025, and to make a half a pot of coffee, it'll cost us 150 watt hours out of our battery. That's no big deal. Okay, my wife's making some bite-sized pancakes. We're preheating the griddle. The griddle is rated at 1500 watts. Maximum estimated running watts 1350. It's 22.5 watts per minute. This is with bacon. With just the pancakes, it should take, and the preheating, about 10 minutes or so. We're looking around 250, 300 watts will be taken out of our battery bank. Yeah, so about 1800 watts being taken out total, but we have our TV on, our lights on, and the coffee maker. And I'll be turning the washing machine, our clothes washer, on in a minute. Okay, so I'm running the clothes washer at the same time that we're running the griddle, the coffee maker, the lights, the TV, the computer. So now we would not do this in a normal power outage when we didn't know, exactly when the power was going to be turned back on. But if we were confident when it would be turned on, like we are now, I just want to show you what it can run, what the Delta Pro can run. The clothes washer is 1500 VA, which is just a little more than the actual running watts. And the estimated watt hours being removed from the battery are about 140. We decided to do a load of dishes while we're washing clothes. And it's 9:30 a.m. The coffee maker's off. Lights are on, TV's on, and it's running about 910. 51% left, 56% left, and 50. Okay, so a little after noon. Our 24-hour simulated power outage has concluded. Let's see how the batteries did. 33% on the Delta Pro, 39% on one battery, and 32% on the other. Now I'm going to be running everything I can think of in the house to bring these down to 0, because I want to recalibrate them, and then I'll charge them to 100% and then drop it down just a little bit. Okay, it's 150 and the batteries are almost fully discharged. That's it. Everything just went out in my home. I got to take care of business. The three most important aspects of any portable power station for emergency power, in my opinion, are how fast it charges, the variety of ways you can charge it, and battery capacity. Well, with the Ecoflow Delta Pro, it definitely charges fast, and there are a variety of ways to charge it, and you can expand battery capacity. Thank you for taking the time to watch my video. If you liked it, please like it and share it, and don't forget to subscribe. Y'all have a great day. Again, thanks for watching.